So let's do some homework problems for 7.5. The first one I want to look at is number 10. In this case, they tell you to solve it. They don't give you any of the equations. We got to create these ourselves. So we're going to read through it. We'll probably have to read through this several times to make sure we have everything we need. But here we go. So first, let's assume that we have a company that makes a profit of $15 per bookshelf and $40 per desk. So we're selling bookshelves and desks. The manufacturer must manufacture between 30 and 70 bookshelves per day, inclusive. That means that they could make 30, they could make 70. They must also make between 25 and 65 desks per day, inclusive. So including 25, including 65. Let X equal bookshelves and Y represent desks. So I think what they actually mean is number of bookshelves and number of desks for X and Y. To maintain high quality, they should not manufacture more than 90 pieces a day. All right, so we need to answer the question, but there's a lot of work that has to happen before I can fill in these blanks. All right, so let's do what they say. X will represent bookshelves. Bookshelves. Oh. And then desks. Okay. And I'm going to put number of in parentheses because that's what they mean. And then Y is going to represent the number of desks. All right, so that was given down here. Let X equal bookshelves and Y represent desks. Now, I have to reread this a few times before I'm done. So let me start with that. They must manufacture between 30 and 70 bookshelves. So that will be X. They must make between 25 and 65 desks per day. That's going to be our Y. Now, this first sentence, they make a profit of $15 per bookshelf, $40 per desk. We want to maximize profit. So we want this thing to be the largest. That's going to be our objective function. So, objective function. Okay, so that means Z is equal to 15 for bookshelves plus 40 desks. So 40Y. That's our objective function. Now, the rest of it tells us our constraints. So now I'm going to write constraints. You don't have to label all of this, but I'm going to. All right, so this is what everything has to live between. We use that sentence. They must manufacture between 30 and 70 bookshelves. Bookshelves are X. So X must live between 30 and 70. Another way I can say X must live between 30 and 70 is to write 30 is less than or equal to X is less than or equal to 70. The inclusive right there means I put an equal sign. If it had just said exclusive, then I wouldn't include 30 and 70, so there would not be an equal sign. They must make between 25 and 65 desks per day. Desks are Y. So 25 is less than or equal to y is less than or equal to 65. Okay. To make high quality, they should not manufacture more than 90 pieces per day. So that means that both X has got to be less than or equal to 90, and Y has got to be less than or equal to 90. All right. So you may already see there's got to be some intersection going on here. Like we already know that Y has to be between here and here, and so we know this is a much broader range than that. So we're going to figure out where all of this kind of overlaps. Okay. To do that, we're going to graph. I may have to come back and do a little bit of algebra, but we'll see. So here's a standard piece of graph paper. But let's be real. If we're talking about number of things, if we're talking about the number of desks, well, you can't have a negative number of desks. We can't have negative desks or bookshelves. So I only need the first quadrant. So I really am only looking at this first quadrant. So I'm going to get a piece of graph paper that's a little more focused on this so we can see all the numbers. Since desks can't be negative, then really this also lives between 0 to 90. So that's kind of an understood restriction because you can't have negative desks or bookshelves. All right, so let me show you another sheet. All right, I found this online. I printed it off. Even though you're not going to have graph paper for the test, I wanted to use it for the demonstration. You'll notice that with like a straight edge or a line, you can get the same kind of graph. All right. So here we go. I'm going to graph all of these things, and if you notice, most of these are inequalities. So not only do I have to graph the lines, I have to graph the inequalities. Okay, so I believe this needs to be fixed. Here we go, look. To maintain high quality, they should not manufacture more than 90 pieces. So I need to modify this. I could have one bookshelf and 89 desks. So really, let's fix that. I could have 2 bookshelves and 88 desks. So really what can happen is X plus Y has to be less than or equal to 90. And then, of course, we can't have a negative number of those. So it still lives between 0 and 90. All right, so let's thinking through it. So this is a line that I can graph and shade, and these are both as well. So I'm first going to graph this guy. X plus Y is less than or equal to 90. Okay. So I'm going to throw away the 0. I'm not worried about it. So let's first think about X plus Y is less than or equal to 90. All right, so how did we graph inequalities? First thing we thought about is you consider the equation. Consider the equation x plus y is equal to 90. And then my math lab wants us to graph using intercepts. Graph using intercepts. Okay. By now you could probably do this without this work, but I'll do this kind of brief. I'm going to find the x-intercept first. The x-intercept is if we let y equals 0 and solve for solve for x. So x plus 0 equals 90. So of course, x is equal to 90. Well, if I do this for the y-intercept, I'm going to let x equals 0 solve for y. Well, you probably see right away I would also get y equals 90. So my x-intercept is 90, my y-intercept is 90. So these are the points 90, 0 and 0, 90. Okay. So let's plot those 2 points. Well, so you may have noticed that my that I've already done that part, putting this on there, just to save some time. All right. So since I did my intercepts red, I'm gonna graph this with the red pen. This is the x-axis. This is the y-axis. X was the number of bookshelves, Y was the number of desks. I may decide to write that in a minute. All right. All right, first line graph. Just kind of got like a triangle going. All right, what's next? I guess we'll do this one here. It's got the x. This creates a vertical line, vertical lines. I guess if I needed to show this. Oh, by the way, I need to shade something real quick. We're not quite done here. I was moving on. I probably should have finished. I graphed the equation. Now let's do the inequality. All right. So graph x plus y is less than or equal to 90. We've got to graph the inequality. Remember what we did? We tested a point. So you test a point. Test a point not on the graph. What I mean by that is test the point not on this line. Well, the easiest, friendliest number to test is 0, 0. So we're going to test 0, 0. So test 0, 0. So 0 plus 0 is less than or 90. Is this true? Yes, it is. Of course, 0 is less than 90. So this is true, so I'm going to shade towards 0, 0. But I want to be careful because I don't want to shade this too dark. I'm going to just shade this very lightly because I'm not going to use most of it. I'm just going to kind of shade this in a diagonal way, very lightly. what we're going to end up doing is shading all these lines, figuring out where things intersect, and that's what we're interested in. Okay. All right, so let's do the other parts. Let's look at 30 is less than or equal to x is less than or equal to 70. All right, so these are vertical lines. This is saying, you don't have to write this down, but this is saying that x is greater than or equal to 30 and x is less than or equal to 70. Okay. And if we want to graph this, I'm really needing to begin with graphing x equals 30 and x equals 70. Okay, these are vertical lines. These are vertical lines. Okay, so I go back to my graph. Let's do this one in purple. All right, I'm going to graph these two lines in purple. So x equals 30. And we look here, there's 30. This is a vertical line. The other one was x equals 70. So x equals 70. According to this inequality, 30 to 70, this means shade between 30 and 70. Okay. So we graph the two equations. Since x lives between those two, we shade between it. So again, I'm not going to want most of it. I'm just going to kind of lightly shade this. I'm using different colors so I can see where things intersect. So far, these two things intersect in this trapezoid right there. Okay. All right, now let's look at the constraints on y. Constraints on y, right there. So 25 is less than or equal to y is less than or equal to 65. We're going to play the same game. We're going to first think about the equation. Okay? We're going to begin with graphing the two equations, y equals 25 and y is 65. And then, since y lives right there, you're going to shade between them. I need a new color. I got a blue. I don't want to use blue yet. I'm going to use this pink. So, shade between. So it's slightly different than the red. Okay. Here we go. These are horizontal lines, by the way. These are horizontal lines. In my last video, I said that this was the longest part, step 1, graphing all of these things. And it's true. All right. So we're graphing y equals 25. All right. I did these by 2, so I got to kind of go in between. So 25, 22, 24, 26, so 25 is right there. We do our best. It could go all the way there. I'm not going to need all of that. It's a little sloppy. I'll redo that. Yep. That's a little better. All right, and then 65, 62, 64, 66. So in between that. And I could shade between those. I don't know, I guess I'll use a squiggly line. Just kind of see. So far, we are in between this little triangle. Okay. What's next? Well, I believe we have looked at all of our constraints. We've got, that was the vertical lines, these were the horizontal lines, that was what we started with. So we got everything we want. So, what happens is this creates a shape. In this case, it looks like we have a triangle. So, we got, so this is a point here. I may have to figure out what that point is. Even with my graph being as perfect as it is, I will need to figure out what those exact points are. Those are our quarter points. So where everything is shaded and kind of overlaps is this blue triangle here. All right, so now we got to figure out what these quarter points are. So back to my paper. All these quarter points. All right, so here's this again. All right, so this quarter point is where the purple line intersects the pink line. The purple line is x equals 30. It's vertical, x equals 30. And then that is y equals 25. So I'll tell you what I want to do. I want to see what this point here is. So first I'm going to find this guy right there. All right, so this one is where x equals 30, and then it intersects, x equals 30 intersects this line, which was x plus y equals 90. So I want to figure out what the ordered pair is right here. Okay. We know that the x value is 30. The y value, well, I can plug 30 into this. So 30 plus y is 90, so y is 60. So I treated this like a system of equations. X equals 30, y equals 90. They intersected. Therefore, y is equal to 60. So these two lines, this purple line and this red line, intersect at 30, 60. Let's figure out where it intersects this pink line. Okay, so let's do that. The pink line was was 25, so y equals 25. And it intersected, so the pink line intersected this red line, which was x plus y equals 90. Since y is equal to 25, we have x plus 25 equals 90. And I am doing a little bit of shortcut, but was that 65? I had to double check myself. Okay. So that means if y is 25, then x is 65. And then this point here, well, that's kind of strange. That's why I saved him for last. This is the line x equals 30, purple line. This is the line y equals 25. And so, yeah, it's tricky because I don't have anything to plug it into. But look, if x is equal to 30, y is equal to 25, that's the ordered pair, 30, 25. Okay, so that guy goes here, 30, 25. That makes sense because it's vertical with that guy. That should be the same x. All right. So, finally, we got a corner point. Now we can finally plug this into the objective function. What was our objective function? I forgot. Objective function is this. So, on another sheet of paper, I'm going to rewrite my objective function. Objective function. Z equals 15x plus 40y. And I'm plugging in all of these corner points. Okay, so corner points. And I'm just going to write out my corner points, I believe. Corner points. I'm going to do this. I'm going to do each of them here. I'm going to do 30, 25. And I'll come over here. We'll do 65, 25. And then the last one, which is 30, 60. So what I need to do is plug each of these guys into the objective function. Remember, this is x comma y. So when I plug this in, that's x, that's y. So z is equal to 15 times 30 plus 40 times 25. Double check that. 15, 30, 40, 25. All right. I'm just going to spit out the final answer here. 15 times 30 plus 40 times 25, 1450. I'm going to look at it again. I would always be careful because there's so many parts that we had to complete, and the final answer only wanted one number. So I double check each of my calculations. All right, again, 15 times x is 65, plus 40 times y, which is 25. 15. So I'm double checking all of this because we already did so much work. 65 times 15 plus 40 times 25, 1975. This 3060 was down here in the bottom corner. I'm going to predict that's the smallest number. That's going to be the minimum. That's my guess. But anyway, 15x, 40y. 15x plus 40y. 15 times 30 plus 40 times 60. Well, looks like this is our biggest number. 1530 plus 40 times 60 is 2850. Okay, the question, where was the question? All right, I'm going to need this still. All right, so how many bookshelves and how many desks should be sold to maximize profit? Well, I guess I was wrong. I thought this would have been the smallest number, but no, it's actually, this yields the maximum. Okay, 3060. Let's see how to type this into the problem. I think I'm going to just write it. The company should manufacture. The company should manufacture blank bookshelves. All right, what was bookshelves? X is bookshelves, X is this, X is 30. And blank desks. Desks were Y is 60. Whoops. So all that work, let me get to that. All right. That took us half an hour, but I went through that slowly as if I was explaining it if we were sitting down chatting about it. You can get through this a little bit quicker, but that's how you would do it.